conventional drive with combustion engines. And now in Poland, hybrid electric vehicles is becoming more and more popular. There are many such cars on the streets due to affordable price, fuel economy, and low exhaust emissions. We have such a model for training of our students. And in my opinion, for now, electric cars are still expensive. Government subsidies are low, and there are still few charging points. Moreover, now electricity in Poland comes mainly of coal, combustion of coal. But we can see perspectives for changes, and we want to be prepared with our education offer. Today, I will introduce another aspect of electromobility, driving cycles. The first driving cycle is a series of data points representing the speed of a vehicle versus time. And first, for combustion engines, driving cycles are used for calculating fuel consumption and exhaust emissions. Okay. For electric vehicles, driving cycle can be used for calculating energy consumption or state of charge of the battery. But although we can have an opposite problem, how should we drive to save energy? Anyway, to calculate energy consumption, we need a reliable model and a realistic driving cycle. We have two ways of finding reliable model for testing driving cycles. First is the mathematical model of electric vehicle. And for modeling, we need many parameters of systems, like parameters of engine, of control system, algorithm of control system. Of course, by using professional system modeling software, we can use ready-made libraries like electric motors, batteries, sensors. In such a model, we can study the impact of a driving cycle on energy consumption, but also we can observe how the changes of other parameters in subsystems influence on energy. The second way of modeling is using machine learning methods like regression analysis or neural networks. It is so-called data-driven models. We get a model in the form of black box. This model can be used only for testing the impact of driving cycle on energy consumption. Statistical models are characterized by simple and fast applications. In fact, for an electric cars or electric vehicles, The problem should be stated in opposite way. What should be the driving style in specific urban conditions to drive without recharging the battery? It is a problem of electric buses or delivery vehicles. In the figure on the left, we can see free cycles as a function of the distance. The cycles were recorded for a Tesla electric car. The red line is for an aggressive driver. The blue line is for calm or eco-driving, and the green one is when Tesla were driven by autopilot. The graph clearly shows the places where the traffic lights and traffic jams were places. Traffic lights. The bar graph on the right shows the energy consumed and travel time for each cycle without stopping in traffic jams and at traffic lights. And which cycle is optimal? Of course, it depends on criteria. Every driving cycle is characterized by a list of parameters. It can be percent of time for speed over fixed velocity, 40, 50, 60 kilometers per hour, mean value and standard deviation of speed, of positive acceleration, of braking, or standard deviation of acceleration, or percent of time of stops, and distribution parameter or acceleration, and we can think about another parameters. Based on the list of parameters determined from the driving cycle, but also we can use other sensors like yaw rate sensor, signal from camera. We can determine the type of driver. We can classify them as calm, normal, aggressive, or according to another classification as eco, neutral, or not eco. We do this using data mining methods, in particular one of the cluster analysis methods. And now about application, our research. This year, the first 10 electric buses appeared on the streets of Radom, our city. We started the project connected with generating optimized cycles, driving cycles for electric buses. The work steps are as follows: collection of driving cycles and other parameters, data analysis and statistics, criteria of optimization of the driving cycle, generation of optimal driving cycle, and last, the most difficult stage is online comparing driving parameters and suggestion for a driver. For our research, we need many data. GPS parameters are recorded by GPS data loggers. They collect GPS position, velocity, acceleration, altitude. but we need also other parameters like state of charge of the battery, acceleration of pedal position, and other. We need to obtain this data from the onboard diagnostic connector or directly from the vehicle's CAN network. Data can be transferred to a computer by wire or by Bluetooth or by Ethernet, or can be transferred to the cloud. Going to conclusions. In our work, we use statistical methods like machine learning, cluster analysis, Markov chains, Monte Carlo simulations, and other elements of Industry 4.0 like Internet of Things, Big Data, and cloud computing. The presented work is in line with the topic of autonomy of electric vehicles and smart city. Thank you for attention, and I hope we see soon in Radom.
Thank you very much, Professor Komorska, for presenting us indeed a different aspect of the electric vehicles, proving that not only technology as we know it goes with the electric vehicles, but also mathematical analysis, statistics can be and are quite useful. If there are no other, are there any questions? Okay, so thank you very much once again for your presentation. And we proceed to the last but not least of today's presentation.